The heart is complicated. It pumps and pushes our blood throughout our bodies, delivering oxygen and nutrients wherever we need it. If the heart stops, we stop. But what keeps it going? And how do we know when something's wrong? Those are questions that you will hopefully find answers to throughout this series. We'll begin by understanding what makes the heart beat and how it pumps blood. And then, with an understanding of how things function, we'll dive into the EKG rhythm, learning how to break down rhythms, identify changes, and interpret those rhythm findings to help us in treating our patients. But in order to really understand why an arrhythmia causes a problem, you have to understand how blood is supposed to flow in and out of the heart. So we begin this series with a video that will look closely at the mechanics of a heartbeat. This is a human heart. But since my artistic abilities are a bit limited, this is how I will represent the human heart. It is made up of 4 separate chambers. On the top are 2 small chambers known as the right and left atrium. Below each atrium is a ventricle, so we have 2 of those as well, called the right and left ventricles. The right side of the heart is responsible for pushing blood through respiratory circulation. Respiratory circulation takes deoxygenated blood and takes it to the lungs to be oxygenated, before returning to the heart and entering the left atrium. The left side of the heart pushes the newly oxygenated blood throughout the body, or systemic circulation, delivering it to all the vital organs and tissue throughout the body and providing the oxygen and nutrients to those areas. Then, once the blood delivers that oxygen and nutrient load to organs, it becomes deoxygenated. The deoxygenated blood makes its way back to the heart, where it arrives at the right atrium and begins the cycle again. That covers the circulatory systems, but we're trying to focus more on movement of blood within the heart itself. So blood enters into the 2 atrium. Then it has to make its way into the respective ventricles, right to right and left to left. Then the ventricles send the blood back out into the appropriate circulatory systems. What is the primary driving force to move blood from the atrium, up top, into the ventricles down below? You may have said, contraction, obviously. And that's a common thought. Atrial contraction is an important piece of cardiac blood flow. But it's actually not the biggest piece. If you watch the animation, you'll notice that even when there is no contraction in any chamber, blood is still moving from the atrium into the ventricles. This is due to pressure differences in the chambers. If we just emptied the ventricles of blood and sent that out into circulation, we currently have 2 empty ventricles, and empty chambers have no blood present to push against the walls and create pressure inside that chamber. So the empty ventricles are currently under very little pressure. But the atrium are receiving blood from circulation pretty much constantly. As the atrium fills up, the pressure inside the chamber increases. With increased pressure, that blood is trying to break out of that confined space. And since we have a huge open chamber right below, that's where the blood wants to go. As soon as the pressure in the atrium is greater than the pressure in the empty ventricle, that increased atrial pressure forces blood through the mitral and tricuspid valves that separate the atrium from the ventricles, and blood begins to fill the ventricles. Currently, all the chambers of the heart are relaxing. There aren't any in a contracted state. This is called the diastolic phase. Diastolic basically means the heart is resting between contractions. Since there is no contraction pushing the blood, I refer to this stage of ventricular filling as passive filling of the ventricles. Passive filling accounts for 70 to 80% of the blood that fills the ventricles. Once the ventricle is 70 to 80% filled, the pressure in the ventricle is equal to the pressure in a fully filled atrium. So passive filling stops because the atrium currently doesn't have the pressure to force any more blood into the ventricle. Until it contracts. When the atrium contracts, the squeeze of that chamber causes the pressure in the atrium to increase. And now, the pressure in the atrium again exceeds the pressure in the ventricle, and the atrium empties its volume into the ventricle to fill that ventricle to 100% capacity. That period where the atrium is contracting is called atrial systole. Systole, or systolic phases of the heartbeat, are where the chambers are contracting. So that contraction that we are trained and programmed to think is the end-all be-all of blood movement actually only accounts for 20 to 30% of the blood that moves into the ventricle. We refer to this final push of blood as atrial kick. That atrial contraction kicked the last bit of blood out to fill up the ventricles. Now we have a 100% filled ventricle. What is the driving force that gets blood from the ventricle out into circulation? You may be a bit gun-shy about claiming contraction, obviously, again after last time. But it is contraction. 100%, it's contraction. There is no passive movement of blood from the ventricles out to the body. The only thing that can move that blood is to squeeze the ventricles and force the blood out. The volume of blood that is pushed out of the ventricles with each beat is referred to as cardiac output. With these contractions and rest periods, we have to look at the cardiac cycle, which is the proper order of systolic and diastolic phases throughout the heart. It's a cycle, so you can jump in wherever you want, but we'll start with the diastolic phase, which is already stated, is the resting phase of the heartbeat. During the diastolic phase, all 4 chambers are in a relaxed state. Nothing is contracting. But as you now know, that doesn't mean blood isn't moving. During the diastolic phase, 70 to 80% of the ventricular volume is being passively moved from the atrium to the ventricle. So having a properly long diastolic phase is very important. If there isn't enough time between heartbeats, that's when the diastolic phase is happening, there won't be enough time to get that 80% of ventricular volume, and you lose cardiac output on the other side. The next phase is the atrial systolic phase. We've got the ventricles filled to 80%. Now we need to top it off with that atrial kick volume. So directly following the diastolic phase, we have atrial systole, also known as atrial contraction. Now, our ventricles should be filled to the brim, and we need to empty them out. So we move to the ventricular systolic phase, where we get ventricular contraction, and all that blood is forced into circulation, giving us our cardiac output. Then the cycle repeats. Diastole, atrial systole, ventricular systole. Diastole, atrial systole, ventricular systole. So on and so forth. Understanding how blood flows through the heart is important when considering cardiac arrhythmias. Each arrhythmia will cause changes in cardiac output, because some part of this process will be impacted. As we move forward through this series, we'll regularly be coming back to these concepts to understand what happens to blood flow when the rhythm changes, and why do we see the impacts that we do. In Part 2, we'll dig into the electrical system of the heart.